So without further ado, let's begin with our opening keynote. Today, it's my privilege to introduce to you our first two speakers at this summit. We have with us Paul Holland, who is Senior Director of Test Engineering at Medidata Solutions Incorporated in New York City. Paul has over 20 years experience in software testing. He specializes in adapting testing methodologies to reduce waste and be more efficient and effective, finding ways to document only that which needs to be documented, and modifying reporting of test activities to provide actionable information to stakeholders and reduce or eliminate potentially harmful metrics. Our second speaker, who will also be joining in the opening keynote, is Huib Schoots. He is Operational Director and Servant Leader of Quality Accelerators. What Huib does professionally, in a couple of words, he is a quality coach, agile expert, change maker, product improver, problem solver, tester, and scrum master. His personal mission is making better people and software quality by connecting, innovating, facilitating, coaching, enabling, and teaching. So to now take us through our opening keynote on automation addiction, please welcome on your screen, ladies and gentlemen, Paul Holland and Huib Schoots.
Hey, good morning.
Good morning.
I hope everyone is doing well, or I should say good afternoon, I guess, in Sri Lanka. I am on the east coast of the United States, so it is 4:47 in the morning. And
it's 11, almost 11 here in the Netherlands.
Yeah. All right. Huib is going to share this.
There we are.
Perfect.
So we want to talk about automation addiction, and the idea for this talk came at the conference where Paul and I were sitting together in the audience, and we saw a presentation of a tool vendor who was, well, basically promising the world. It was like their tools did everything, and we didn't need any testers anymore, and everything would be automated. And Paul and I just walked out the room like, this is the worst talk we've ever seen. And in the hallway, we started talking, and this talk came from it. Beware that we're not against automation at all. We think automation is great, but we see a lot of people who are addicted to automation, who think automation can solve all their problems. And well, that's simply not true. So who are you, Paul? Although I was basically introduced already.
I was introduced very, very nicely. So I'm who Trishma said I was. So there we go.
Yeah, me too.
Yeah.
So let's continue
Good
with a small disclaimer, and then let's talk about what is automation. And just to be a little bit cautious here, because everybody talks about automations, but there are so many different kinds of automation. So let's dive into that a little bit. But before we start with that, we found a quote, and we don't know who made it. So if you're in the audience, let us know. We are happy to put your name under it. To us, automation is adding more unreliable code to the stack of unreliable code, because code is always a little bit unreliable, that you already have. Think about that during our talk. Paul.
Right. So when people just say, I write automation, or they're asking, just talking about automation, what do they actually mean? They could be talking about a particular activity. So something like what's listed there, data collection, data generation. You could be talking about I might be talking about unit testing. I might be talking about integration testing, or API testing, or end-to-end testing. I could be talking about the architecture. So I'm talking about a particular feature. That's fine. Anyway, my point is there are lots and lots of different types of automation, and the word automation is very generally and generically used. Now you can go to that slide.
Awesome.
So with so many styles and types of automation, if you want to have a good discussion about automation, you need to be specific. You need to be saying, are we talking about unit testing? Are we talking about integration testing? You need to be very specific. But go to the next slide. We're going to do this keynote actually not being specific. So by what I just said, this will not be a good discussion about automation.
But it will be a good keynote, we promise. So what is this automation addiction we're talking about? And already it gave it a little bit away when we started this presentation. Many people talk about automation, and many people seem to think that by using AI or machine learning and all kinds of fancy tooling, the tooling gets better and better, that they can solve all the problems by automating it. And we put that in a little comic.
Yeah, we also made a bit of fun about how testers are often complaining and pointing out mistakes and errors. So if you replace all the complaining testers who are finding all the problems with automation, you're going to save money and find all the bugs.
But
however,
let's see what happens. Here's the CEO 18 months later.
Yeah.
And of course, this is just making a little bit of fun, but there's a true story behind it, and we're going to share those stories with you later. So there are many symptoms of automation addiction, and this is just a list. There are probably way more. So trying to automate too much or everything. And I know companies who have their automation strategy, it says automate all, which cannot be done, but it's good to have a lot of automation. Trying to maintain ineffective automation, so you know that your automation is flaky, or that you know that, well, there are holes in your coverage, but you're still gonna maintain it because, well, it's there and it doesn't cost us anything to run it, and running it is not the problem. It's maintaining which is the problem. Trying to replace testing or testers with automation. And yes, we don't need people to do repetitive things. We can automate that. So for regression purposes, it's fine. And if you're still doing that manually all the time, maybe those testers can be replaced. But all those other testers exploring, learning about your problem, finding those juicy bugs cannot be replaced. Implementation of problems because somebody just bought a tool or has a license for a tool and say, hey, you really need to use this tool or this system. And teams get into trouble using that. The sunk cost syndrome. It's, well, we paid so much for this part of the automation that we don't gonna throw it away, even though it's flaky and it's not really helping us. But hey, we spent years building it, so why throw it away? Or testers who turn into software developers in testing and only focus on automation. So their job is to find bugs and to help prevent problems and to ask difficult questions and to make people aware that there are risks. And then they start learning about automation and they focus fully on the automation. Paul.
And well, this is something that gets, in my mind, exasperated by our current situation of working from home and not being able to be in the office and discussing, not having the immediate social interaction and being able to bounce ideas off each other. If I've been shown a tool, or if I've been working on my particular thing at home to get better at Python automation, I might get more ingrained in that, or hey, I was just shown this wonderful tool that does capture replay, and so because I'm not integrating and talking with other people outside my own little world as much, I might be more inclined to get stuck in a particular situation instead of seeing what else other people are doing, which you do by being in an office and walking around. So you need to be a little bit more aware of these situations as you're going through.
So fixation on test automation and now AI is causing us to lose the connection with the human social purposes of software development and testing. We'll dive into that a little bit more later in this presentation. But this was something a participant in the automation and testing training said. And I was struck by it because the purpose of software is to help humans solve their problems. And automation is far from that. So think about this. Paul, tell us about fairy tale marketing.
So one of the things, as Huib already said, that got us wanting to make this talk is after we left that discussion, that presentation at another conference, we started to look at emails that we receive or web pages that we come across, and seeing things like this one. And these, we put the attribution on here saying that the properly automated testing offers a tremendous return on investment. Well, one, testing never offers a return on investment because it's like an insurance policy. It only offers a return on investment if we find a bug and fix it, but we don't know what bugs would have been found anyway. So it's like saying, the fire insurance, you hope you don't need it. But look at the 7 benefits that like decrease costs. Really, if you're going to automate everything, you're guaranteeing, without knowing my situation, that you're going to decrease my costs or increase my coverage, increasing my test accuracy. There's so many wrong things about what this particular claim. And let's show the next one. The Tricentis, which is typically a wonderful company. Actually, James Bach, who is a colleague of ours, is consulting with Tricentis right now. But every so often, there's somebody at a company in a position who will say things like, testing costs cut in half and reduce timelines by 90%. What? Like, how do you know that? Now, it does say as much as, but I can cut the testing time down to 0 by just not doing any as well. Like, there's so many things that we can do. Improved reliability. And then this last one, and this is the one that really made me want to do this talk, is this last one that I got in this email. Can you show the last one? Hi, there we go. So this person, told me that without knowing anything at all about me or my situation, that they were going to reduce manual testing and regression testing efforts by up to 60% and reduce operating costs. Like, I don't think you can tell me that when you don't even know what situation I'm in. So just be aware of fairy tale marketing, and also be aware that they are doing their best to sell a product, not necessarily fix your problems. So let's move on. So
why don't you want to automate everything? And software is complex. Software, especially modern software for banks or insurance companies or the big corporates, consists of millions of lines of code. And there's nobody around in those companies who knows the software front to end and who knows the whole system. It's all captured in many people's brains. So it's super complex. And if you change a little thing in the left upper corner, what's going to happen to the stuff on the bottom right corner? Nobody really knows. So of course we need to get that insight and overview to know what we're doing. But it's so complex. And what makes it even more complex are humans. People who are building this software. We've got all different kinds of people, and not only in color, but also in thinking and in gender and in ways of communicating and in how they prefer working, introverts versus extroverts. And these people have to work together, and they have to come up with solutions for all these complex things. And even more important, they have to understand the other human being, the user, on what he really wants or what he really does. And it's really hard to understand. And then to make it even more complex, we have emotions. So we get biased, we get emotional when people give us feedback, or if we feel that we're not listened to. So then irritations start, and communication gets even harder.
So something that automation cannot ever do for you is helping you address unknown unknowns. So those are often referred to as risks, but the problem is they're risks that you're not necessarily aware of. So if you have a human who's involved in the process as a tester, they have the capacity of asking questions, of indulging their curiosity, of being creative and trying to figure out what things like your customers and product owners actually might want or will do with your product. Something like scanning a fingerprints scanner, something that today, you unlock your computer by just scanning your fingerprint. A friend of ours was testing that about 20 years ago now, and they had, as an example, a customer, their biggest customer, didn't use a single scan of any digit to do one thing, which was what their use case was. They used individual finger scans for different actions. So if I scanned my index finger, I'd unlock my computer, but if I scanned my middle finger, I would launch Word. If I scanned my ring finger, I might launch Chrome, something like that. And they had no idea that their largest customer was using their product in a different way. So having the imagination and the creativity to try to figure out what problem your customers are going to solve, that's something that literally you have no capacity of doing, especially with automation. Also, development team doesn't know what they're doing, and you're dealing with the complexity, confusion, as Huib said, the human emotions, the changes, only having partial answers. Something that automation, even machine learning or artificial intelligence, isn't necessarily going to be helping you with. Let's talk some stories, Huib.
Okay, you have a story to tell. So
I do. I worked as a consultant about 4 years ago for a large American insurance company. They had a wonderful, wonderful automation framework. They had a team. It was a small team of about 4 people that were dedicated to creating and maintaining this framework. The framework allowed them to have release all of their routines were dereferenced, so that meaning that when they called a routine to log in, everyone used the same routine. So if there's a change to the login, everyone used that one. So it was well written. It had automatic retries. It detected timeouts and things like that. So it was a wonderful, wonderful framework. One of the best ones I'd seen. They'd written over 2,500 scripts. And if you know anything about test metrics, you'll know that 2,500 scripts is nothing. We don't have any idea what that means. Actually, counting scripts is like counting file folders in an office to determine how good the business is. It's useless, but it's at least a number to give you an idea. They were testing every written requirement. For every single written requirement, they had at least one automated script, a dedicated script for each requirement, at least one. Every time they executed their routine, it was a web page for auto insurance quotes. Every time they executed these 2,500 scripts, about 40% failed. Now, they were being executed offshore, so it was an American company, and the scripts were being executed overseas. They had 13 outsourced workers that were in a different time zone, and it would take them 2 weeks to get these 2,500 scripts executed and identified which ones failed, and then they would re-execute the ones that failed. And if they then had to figure out where the failures were coming from, and on average, this team of 13 people were finding 6 defects a month. So about one defect for every 2 person months of effort. And I just sat down with the test lead in the US, and we pair tested. So I sat shoulder to shoulder with him for 20 minutes, and we found 5 bugs. And of those 5 bugs, 3 were majors that needed to be fixed. So the point is, they were so heavily reliant on automation. I made a recommendation to them. I made multiple recommendations to them in the consulting. They took all of my recommendations except for one, and the one they didn't take was as a result of sunk cost syndrome, which we've already mentioned, and we'll talk again. But I recommended they throw away this automation. It was a safety blanket that was protecting them from a fire as much as a little blanket would protect you, not a fire blanket, just like a, I recommended they throw away their automation because it wasn't working for them. It wasn't effective, and that they start from scratch with a better approach. Again, we'll talk about that later, but they wouldn't. They did all of my other recommendations except for that one. So there you go. Huib, you have a story.
Yeah, and we have many stories. In preparing this keynote, Paul and I were sharing stories, and coincidentally, we both came up with an insurance company story. So it's not that we only do insurance companies, although it may look like it that way. So I did a project as a test manager in a huge product in a Dutch insurance company. We were rebuilding a life insurance system with over 100 people. I was the test manager. I had a team of like 25 testers, of which 3 of them were full-time test automation engineers. They didn't do anything but create test automation, maintain the test automation. We had a good quality software, and the customer was really happy with us. And we had approximately 24,000 checks running. And it could have been 32,000 because it's hard to really count them, but there were a lot. And as Paul said, it doesn't tell you anything.
It's important to count them.
Exactly.
It's a number.
It's a good figure. As soon as it passes the 1,000, managers love it, but it doesn't tell you anything. And then one day, there was this guy standing next to my office, next to my desk, and said, "Hey, are you the test manager? I want to talk to you." And it was the director or the senior director of life insurances. And he said, "We have a bug." And it turned out that the new release of the system sent out a letter of the monthly deposit to all the customers, 700,000 customers, which was calculated wrong. And that's the death in the insurance business. You don't send out letters to customers which contain wrong numbers, because people get upset and they start calling, and sometimes you even hit the newspaper, although this bug didn't. But our service desk was overloaded with people worried that something has happened to their insurance, because people do check those letters. And what was wrong? What went wrong was basically very simple. We had an oracle, and an oracle is a mean to recognize a problem, to calculate this life insurance deposits, because it's a really, really complicated thing to do. So we created the system, and we programmed something in another tool to check if the system was doing it right. And we automated the checks. And we thought we were safe because we had so many checks and the quality was good. And then this bug happened and we didn't see it. And a normal person would have seen it instantly, but our automation missed it. So we were relying way too much on the automation, and we missed a very important, pretty obvious bug. And I had a lot of talking to the team, but also to the directors to explain what happened. And well, we had to admit we were wrong because we were relying too much on automation. And this story indicates that automation really helps you go fast, but these new introduced bugs are not always found by automation, because automation doesn't learn. Automation is made to check if it's still the same, and something changed, and we didn't see it. So what can automation do and what can't it do? Paul?
Well, what it can do for you if it's done well. So we're going to have two categories of what automation can do. One is if it's done well, and one if it's done poorly. So if it's done well, it can allow for CI/CD pipelines, continuous integration, continuous delivery pipelines. That'll give you faster delivery. It'll give you a good sanity check of the system. It's not going to suddenly start finding bugs that it missed in the past, but it can give you something that used to work. Does it work now? That's a sanity check. It's not going to be exploring or being creative or now there is some automation that may be able to do that, but that's very exceptional. It can increase the frequency that you run these tests so that maybe you can run them on every single check-in or maybe every day as opposed to once every 2 weeks. It will free up your testers from looking for obvious bugs and doing simple regressions or looking for simple regressions to being able to look for deeper bugs. So that's a very, very good thing of automation. It will give you a faster feedback on issues if you do break something that used to work. And it can also do something, and this is, in my mind, one of the bigger ones. It can do things that a normal person would get bored or get careless with because it's tedious or it's long, complicated. So automation is very good at doing things that are boring, tedious, long, repetitive, that type of stuff.
What else?
If you're, good point. We have 2 slides on this. So something that it can do is it can reduce the number of exploratory testers that are needed, not eliminate them by any stretch of the imagination. But if you are building up a good base of automation, you will likely not need as many exploratory testers. You can go, if you're in an agile development situation, you can go from having testers, exploratory testing on every story to perhaps doing exploratory testing at the epic level, as an example, because the confirmatory tests have been automated so that you can say, yes, that story does what it's supposed to. And then when you plug all your stories together, then you have someone doing exploratory testing. That's something that I've seen done very successfully, including where I work. Doing data collection, data input, doing calculations, things that computers excel at, why not let them excel at it? Monitoring systems, this one is key. You don't want to have a person sitting there watching your CPU utilization saying, oh, it's at 25%, it's at 26%, 24%, oh, it's up to 28%, 29%. Like, nobody wants to do that. So automation, monitoring your system. And it can decrease certain risks. By doing all the things I just said, certain risks can be reduced.
But definitely not all the risks. So
definitely not all risks.
So what can automation do for you if you do it badly or poorly? And in our experience, that's often. Automation is hard to get right. It's hard to do. We'll come to that later on how you can solve that. So what happens if you do it poorly? Well, costs increases. Yes, you'll get more or you get faster deliveries, but in the background, if you have flaky tests or if you have a platform that's not really helping you, you need a lot of maintenance, then you need more time to run those tests. You need more time to investigate, because it's not only running the test. If a flaky test shows red, or even if a test shows red, you have to evaluate what's going on. Is it the test? So there's a lot of analysis behind it. The execution time will also increase because of all those investigations. The product coverage will decrease because you will only have coverage on the parts that you can automate, and it will take you a long time to run those. Just imagine you have 100 minutes to do testing, and each test takes 1 minute. Then you can run 100 tests in 100 minutes. But each time something goes wrong and it takes time, like 1 or 2 minutes, it will take away time to run new tests or to create new tests. So your product coverage will decrease. It's super annoying to always look at those flaky tests or always look at like, what the hell is wrong now? So it demoralizes your team. And just people say, I don't want to look at it anymore. Just take it away. Trust in your automation declines. I think we need automation, especially in those pipelines. We need good sanity checks to go faster. But if it always goes wrong and it's more expensive, then managers will say, hey, you know what? We'll do it manually, which is also not the solution. So there are a lot of risks that will increase, because if your product coverage decreases, if you have demoralized employees, then there will a lot of the real risk will pass unseen. So what can automation not do for you? As said, it will not replace the need for human testers. Paul explained that even you might gonna decrease the number of exploratory testers. That's absolutely true. But you need people to click through your software and learn about it and see those unexpected things like, what the heck is happening there? It will not decrease your cost. The tester reduction costs are replaced by the software developers in testing and the hard-end software. So it will not decrease your cost. It will probably cost you more. But if you do it right, you can keep the cost at a steady level. It will not increase your product coverage. Yes, you can do certain things humans can't, but many things people cannot be automated. Learning, finding new stuff, being creative. So it will not increase your product coverage, and it will not save you time, because it will take you more time. Problems with automation, Paul.
Right. So a lot of the times, the problems that Huib and I have seen with automation is people trying to automate everything, trying to automate too much. So when I worked in telecommunications a long time ago, our senior VP in charge of our whole business unit said, our goal, he told this to the entire team, our goal is 100% test automation. And a little part of me died inside, because that is not a good goal. Our goal should be automating what makes sense, not 100% automation. If I have something that's going to take 2 weeks to automate, but it takes a human 1 minute to execute, I should have the human do it in 1 minute than spending 2 weeks to automate it, because it's going to take me a very, very, very long time to get back that investment. Plus, if it's complicated and difficult to automate, it's almost definitely going to be something that's flaky and requiring too much time to debug. Thinking that if you have more automation, you're going to be finding more and more bugs on an ongoing basis. Automation is not going to find bugs on an ongoing basis. If you don't change the code in a way that causes the automation to no longer pass, then the automation that passed yesterday will continue to pass today. If the automation is going to be missing bugs. Humans miss bugs, automation miss bugs. The difference is the next time a human does the test, it's going to do it hopefully differently, so it might find a bug, as opposed to the automation, which is just going to do it the exact same way every time. And every bug that it missed the first time, it will continue to miss. A lot of times companies don't even think about next year. Once I've automated all of these hundreds of tests and things that I want to check, what's that going to cost me in the future when I make a change, or if I want to refactor my code, or the flakiness factor? You're almost always going to have something that failed because of a reason you didn't think of, whether it's a timeout, a network issue, a link is down. All of the failures need investigation. That's a future maintenance cost. Plus, this is something we haven't mentioned yet, automation silos. This is what had happened at the insurance company that I worked at. Every single story treated itself individually. So I had a story that was to add a box that said, what state do you live in on the page? And so I wrote a test that went to navigated all the way to that page, and it clicked on the drop down and it made sure all the states were listed there. That's an inefficient use of automation, because I could have added that one test to a series, like a path through the code to go to that page and look at it in a drop down. When you're trying to automate something that a person can look at, I can look at a web page and I can say that's correct or that's incorrect, usually within a few seconds, at least for the overall look. To automate something like that is very, very difficult to do and very unreliable. It's very flaky. Also, something I've seen before, especially if people are being measured on how much automation they write, they will automate stuff because they can, and it's quick and it's easy. But then you're just throwing a bunch of crap on your automation that should be helpful and useful. If you automate things just because you can, you're going to get bloated automation, and it's going to be costing you for maintenance in the future. Also, if you're automating tests that if they fail, no one's going to fix, then you shouldn't have automated it. If I say, you ask your team before you do the automation, if this test fails, will we stop and fix it, or are we just going to keep going anyway? Because it seems unimportant to me that we're going to check this every single check-in. And the answer should be yes. If it fails, we're going to stop and fix it. And if it isn't, then question, why am I automating it? Because it's just going to add to the pile of failures that we have to investigate each time. Also, one of the things that Huib and I promote is you should be automating at the lowest level you can. If you can do a unit test instead of an API level test, or an API level test instead of a GUI level test, do it. You want to test your business logic at the API layer and lower. You want to test end-to-end flows, workflows at the GUI level, and everything else, in my mind, most everything else should be at a lower level. And finally, if you don't have a good automation strategy before you start, you will likely end up committing all of the flaws that I've already talked about. You need to have an automation strategy that identifies what type of things you're going to automate, what type of things you're not going to automate, why, how you're going to maintain it, things like that.
So we already talked about the sunk cost fallacy, and we're going to do it again because I think that's a very important source of problems. So not willing to discard ineffective, flaky, or obsolete scripts. I think a good test strategy for automation also has a part where we look at the test and say, hey, this is not really valuable anymore. Let's throw it away. How many teams struggle with, oh, our build takes way too long because the testing takes 2 hours. That's because many teams do not dare to throw stuff away. So step back and once in a while and check if the current value of your old automation which you are running day by day is still there. And if it's not, like Paul's story, just throw it all away and come up with a better plan. Also, there are many other problems, like automation written by unskilled or unmotivated people. It's programming, it's development. So all rules for good development apply to automation in testing as well. So if you don't do code reviews on your automation or static analysis or all those things like peer reviews, then you're not doing it right. It's production code, because can you release your code without running this automation? And if so, then it's maybe not important enough. So think about that. Scripts created independently by different teams instead of a unified approach, especially when more teams are working on the same product. And every team is doing it differently. Then it becomes really hard to maintain. Because, hey, this stuff is built by Paul's team. I don't want to look at it. They have to do it. Well, I'm running the test and I'm seeing the problem. So there's something in there as well. Or as we already mentioned, it's a tool we know, or somebody told us to use the tool, or, well, we're in a big firm and we already paid the license, so let's use this tool. And it's not the right tool to use. So it's going to give you a lot of trouble. Or, and this is one of the most important things that I see, automation not being part of your daily routine or putting it in your pipeline when you have one. So there's somebody in the team, or maybe somebody in another team, running the automation, and we're not really sure what he does with the results. It's your software, it's your automation. So the whole team should be involved, and you should check the results daily. And it should be discussed in refinements and in retrospectives. How are we doing? So make it part of your daily routine, instead of you being a tester somewhere in a corner doing, I don't know, dusky stuff that nobody knows about. So listening to all this stuff,
I believe you.
How do you convince your manager or your team, or even your whole organization, to do this? Paul, help me.
Well, Huib and I have been doing this for a very, very long time. Combined, we have over 50 years in testing. Yes, that does mean we're old. We often fail at convincing companies. We've been both paid a lot of money to go in and consult at companies, and I tried to convince the large insurance company in the US to change their approach to automation. They changed their approach to exploratory testing. They changed their approach to how they handled requirements. They changed everything. They wanted to change the automation. They heard what I was saying. They understood, and then they wouldn't change. But we have had some successes, but we'll cover those now. But they're kind of few and far between. So here we go.
If we can do it, why should you try? Well, of course, we've been doing it and we've been unsuccessful because it's really hard to change the whole organization. And that's why we call this presentation Automation Addiction, because it's deep. It's rooted deep in the minds of people, and even sometimes in the hearts of people. So to be heard, you need more voices speaking out. So you're not gonna break this addiction in a single conversation, and maybe not even with only your team, but starting your team. Find other people who are willing to change. Keep repeating your message. Don't try to convince the whole management if you're not hired by that management to consult for them, but work with the teams. So start small and start improving. Take these lessons from this presentation and start talking with your developers or the others in your team. What can we change to make it more successful? And here are some ingredients that might help you.
So one of the biggest problems that we've seen is when companies decide to automate and have start to make that big investment into doing their automation, or even if they're not starting automation, after a while they say, we're spending all this money on automation, let's replace our exploratory testers with automation, or let's get rid of the testers in general. So why you need to fight against that, talk out against it, and try to explain why keeping exploratory testers is important. Most of the testing that gets executed in a time-wise and effort-wise will likely end up being automation as we move forward in our lifetimes. However, keeping exploratory testers is important because we've already said these points, but this is a summary. Automation, whatever it checked yesterday, you run the same test today, it's going to check the same thing today. There are some very few exceptions where the automation might actually do some sort of randomness, or but often in those cases, You still need a human to interpret the results. Automation is typically not going to be testing deeply. It's going to be doing a sanity check. It's going to be doing, even if it's doing a particular business logic test that's very complicated, and the business logic is very complicated, the way that automation works usually is it's going to give the same information at the beginning and expect the same information at the end. And maybe the business logic works perfectly for that situation, but if you change the numbers up a little bit, it's going to not work. Automation is not going to find bugs that it already missed. So if you imagine you're looking for an Easter egg, so there's eggs hidden in a house, and the automation walks into the front door, looks in the hallway, turns left, goes into your bedroom, into your living room, looks behind a cushion on the couch, looks behind the curtain, walks into the kitchen, it looks in the refrigerator behind the milk, puts the milk back, closes it, leaves. The next day, the automation comes in, it looks around the hallway, goes into the living room, looks behind the cushion on the couch, looks behind the curtain. Meanwhile, there's an egg sitting right there on the carpet, and it never saw it the whole time. Automation is not going to be able to find those types of things because it does the same thing over and over again. To be able to find good bugs, you need to indulge curiosity, you need to be creative, you need to be able to explore, learn, and modify how you're testing based on what you're learning.
Cool. So the second ingredient is the importance of a good test strategy. And with a good test strategy, we mean a strategy helps you guide the tests you want to do and the checks you want to automate. So it should help you create scripts that test the entire system, but reduces the execution time, reduces maintenance, and reduces redundancy. So think about it. What are you going to automate, and how are we going to automate it? And who do we need input from? Also, pick the right tool and framework, not just a tool that you were told to do or it's available. Think about it. So think ahead. It's an important choice you're going to make. So don't make it overnight, but think about what are we going to do in the future. Also, a good test strategy should help you overcome the sunk cost fallacy, because test strategies change over time, because the context changes and the way you work might even change. And then you step back and say, hey, wait a second. Now our strategy has changed. Do we really need this part of the automation? And if the answer is no, then throw it away.
So don't try to automate everything. We've touched on this throughout the keynote. Your execution time is going to increase over time. Your product becomes more complicated, you add more features, you're going to need to add more automated checks. If you just pile on the checks without integrating them into a thoughtful strategy, as Huib was just talking about, and you're not willing to throw away tests that are no longer important, the execution time is going to balloon out of control instead of just incrementing linearly. The effectiveness of that execution time also decreases. Initially, if you're using Travis or something like that to run your tests on a check-in, it's probably going to run in a couple of minutes. As your code grows and becomes more complicated, that's going to go up to a few tens of minutes and then potentially even longer. So you want to be able to make sure that you're not automating absolutely everything you can just because you can. Scripts, whatever you automate, you're not going to be provided insight. Your script will just say pass or fail. There's no explanation. There's no rationale behind, oh, this failed because of this. That takes a human. And the more scripts you have that are failing or flaky or potentially failing, the longer it's going to take to get all of those insights, or to have humans say, hey, we don't appear to ever test that thing. Automation isn't going to be telling you, hey, that thing over there just gets brushed by. We have a test that covers it, so our coverage metrics pick it up, but it's not actually telling you that piece of code isn't tested in depth. Don't forget about maintenance costs. The more you automate, the more you're going to have in maintenance costs. So make sure that the checks that you are automating are going to get cause a fix to happen in the code. Because if they're not, don't automate that particular check, because you're just adding another scoop of unreliable code on top of your code. The customer focus aspect, if you're automating everything, you're going to lose the customer focus aspect of testing. Testers should be an advocate for your customers. You should be able to use the product like a customer would. You can also use the product the way a malicious customer would, not even a customer, but someone attacking your system, or a confused customer who accidentally pastes 5 pages of a Word document into their password on your system. Those are the types of things that if you think about it and you automate it, automation will check. But why would you want to check that every single day? You probably want to test that, once every 6 months or something. And you can remind people of the insurance company stories, both of which had way too much unreliable and not the correct automation. So
let's
takeaways.
Back to what we said. Robots can replace human thinking, cannot replace human thinking. Creativity or reason. Sorry, yeah.
It's a big difference, Huib.
It's a very big difference. To think of finding new bugs versus sanity check. Sanity checks, computers are excellent at that. They just check if is this code still there? Is this screen still there? Is it still the same as we used to see? While finding new bugs, stuff that is like Paul said, the Easter egg that's right there on the carpet. If you don't check for it, automation won't see it. Try to notice bad automation situations early. So if you see like, wow, we might have chosen the wrong tool, or this tool we predicted that we had low maintenance cost and the maintenance is going up. Start talking about it. Point out those problems before the sunk cost fallacy occurs, because then people will say, well, we've been spending 3 months on this. We can't throw it away. We need to continue. And also remember what automation can and can't do for you. Go back in the slides. We're going to share these slides with you and check the lists we made. Paul.
Don't try to automate everything. We've pounded that one to death. So there's, again, as Huib said, we're going to be sharing the slides with the organizers. So hopefully you'll have access to this, and hopefully you can have the discussions at work. And please, before you start automation, or if you've already started automation, maybe ask to take a step back and say, we should have a comprehensive test strategy that the whole team can agree upon, so that you can look for increasing the testability, making sure every element in a web page has a label associated with it. All of those types of things can be part of this automation test strategy. Angie Jones has a wonderful site, Test Automation University. One of her free courses is how to create a test strategy document. I recommend that for everybody. And please automate responsibly. Go ahead, Huib.
You can do that, and you can do that because I think we haven't mentioned the word testability enough in this presentation, and everybody's working from home currently, and that decreases testability, because testability is something that you need to discuss with your team. The test automation strategy and the test strategy itself is something you really need to work on with your team. So to be able to automate responsible, first apply some of the things we told you in this presentation, but also make sure that you meet with your team on a regular basis to discuss your test strategy, to discuss testability. And remember, testability is never built in because people think it's important. It's only built in because we ask for it as testers, or as a team, we become aware and say, hey, this product is not really easy to test, or it takes us too long to create automation. That's a testability problem. Start discussing it with your team.
And asking for testability before development starts, or very, very early in development, it's easy to add testability. Once the development's done or it's very well progressed, it becomes an amount of technical debt, and it's very difficult to get a tech debt story moved up from the backlog into your active lists, because for the sprint, because people just want to push out features, people want to get everything going. So ask for testability early. That will make your automation, one, more reliable. If you have a label instead of having to use a complicated XPath, you will have a substantially more reliable automation. So asking for testability up front is important. I think we're going to have about 9 minutes for questions. If Trishma, if you want to see if anybody has any questions, we'll see if we can answer them.
Yes, we do have a few questions. We'd like to start off by asking you a question that's just come in from Malit, where I'm sure you can see it on your screen as well. You suggested doing exploratory testing in the epic level, but not in the story level. Isn't it a violation of agile practices, and isn't it costly to identify bugs at the later stages? Would you like to take that question?
That's a good question.
The costly aspect of finding a bug later, there's a wonderful book by Laurent Boissavit called The Leprechauns of Software. Boissavit. Boissavit. That's what I said. It's French. You don't speak French.
Stupid Canadians.
Called The Leprechauns of Software Testing. And one of the big myths about software testing is the fact, and I put air quotes because it's not a fact at all. There's actually no study done, no proof that the later you find a bug, the more it costs. Most of you are now going, what? I was told that in school. I was told that in school too. Guess what? I went to school back in the 1980s before most of you were born, and that myth was propagated there. What Laurent did is he went through all of the papers he could find, all of the actual proof, and there was no proof anywhere that finding a bug later, intuitively it might make sense, but when you think about it, maybe if I find a bug later, I'm not going to fix it. That makes it quicker, cheaper to find a bug later than earlier. There's lots of situations that you can disprove that statement if you just think about it. And as I said, there is not an actual study. Laurent looked for one. He found references to that statement, but there was never any study to back it up. But also, agile processes are meant to be flexible. So there's nothing written down that says you must do this exact thing every single story. The purpose of agile methodology is to be flexible and to change how things operate. So what we've done at my company, I'm not saying we don't do any testing at the story level. I'm just saying that we reserve most of the effort of exploratory testing up at the epic level. So at the epic level, when you find a bug, it's still going to be within a sprint or a few sprints at the most of when the bug would have been introduced. And most of the difficult, hard to figure out bugs are going to be at the epic level anyway. I might have a perfectly developed story here and a perfectly developed story here, at least at the story level. And when they go to talk to each other, guess what? This one has an int, this one has a long int, and there's interaction problems that can't be found except up at the epic level. So if I do my good automation confirmatory testing, getting great unit test coverage, some API business unit logic tested there, and then I do my exploratory testing at the epic level, I'm going to be more effective and efficient with the testing. And by effective, I mean I'm going to be using fewer testers because I can have fewer manual testers or exploratory testers. But I'm not saying if you have the capacity, definitely do the testing earlier. Sorry, Huib, go ahead. I did what you did
No,
last time.
I was just
talked too long.
waiting. That's a long answer, and you forgot the most important part. We didn't say that you only need to do exploratory testing on the epic level and not on the story level. That's not what we said. And if we did, then I'm sorry, because then we were wrong. Because you need to do exploratory testing on every level, but
you can focus the testing at the
Exactly.
epic level. Yeah.
So you need to think about where to put your efforts. And again, as Paul said, the costs don't go up exponentially. Of course, you want to find bugs as soon as possible.
You got to get to the next question.
Exactly.
It's 5 minutes on one question. Okay, quicker answers.
Okay, so the last question we have time for right now. This one comes from Nuwan, and this says, when designing automation framework, what are the factors we should be considering, the technical and the non-technical factors from a customer's point of view?
Wow, that's a broad question, and I cannot
Yeah,
answer it without knowing
Yeah.
the context. But let me give you a couple of pointers. When designing a test automation framework, one of the major things you need to do is before you start designing the framework, is go to your team and discuss with your team or with the department, what are we trying to do here? What does this framework needs to do? And what will be helpful for us and what won't? And then look at the context. Do we have people that can do this? Because people are part of the context as well. So there are many considerations that you can have. Non-technical factors are, do we have maintenance capacity, or do we want to buy a framework, or are we going to build it? How fast does it need to be? I worked for a telecom company, and while back in the days when we were building SMS servers, there was no test tool in the market that could keep up with the speed of these servers, because they had to be able to do 25,000 messages per second, and there was no test tool who could do that. So we built our own.
Okay, thank you so much for your answers. We do have a few more questions. We wouldn't be able to take them right now, but perhaps Paul and Huib, if you can let us know how they could contact you, so they could get their queries answered.
Let me show you immediately how they can contact us. There you are. Send us an email. Find us on LinkedIn, especially LinkedIn works for me well. Just add me to your contacts, ask your questions, and I will answer them there.
Fantastic.
I think for Paul it's the same.
Yep.
Yes. All right. So on that note, thank you very much, both to Paul and Huib, for very, very enlightening opening keynote at our summit. We thank you so much for joining us here today.
Thanks for having us. It was a pleasure.
Thank you for having us.
Bye.
Bye-bye.